Okay, guys. Here it says, using the formulas on page 206 in the brown box. This will take a few lessons. You better believe it. So what we're looking at on the brown box in page 206, which it says cosine sum and difference formulas. Here's the deal with this. If I want to take the cosine of something, like a 45-degree angle, I know how to do that. I can find the cosine of 45. I can find the cosine of 30. Heck, I know 60, I know 90. There's all kinds of different angles I can take the cosine of that I have memorized. But there are definitely some that I don't have memorized. I'm going to explain that in 1 second. First, quickly, I'm going to jot this down. The cosine of angle A plus angle B is what it says on page. This is the formula. You take the cosine of whatever angle A is times the cosine of whatever B is. Subtract from that the sine of the same angle A and the sine of that same angle B. That is called the sum formula. I'll explain. Don't worry, we're going to do some examples. But here's the deal with this. During the regular school year, I make people memorize all these formulas because the more you have memorized, the easier it is to get this stuff done because you don't have to, rack your brain for what is the formula for this, what's the formula for that. So I call this one couscous because I like couscous. But I think of it because it goes cosine, cosine, couscous, couscous. And the letter pattern is the same. Couscous, it's AB, then it's sine A, sine B. The only thing is cosine's a jerk because the sum angle formula, the sum formula, they put a minus in the middle. And then the minus formula, they put a plus in the middle. But what does that all mean? Well, I'm going to do a couple examples for you so you see what they're talking about. So the first one I'm going to do is going to be this. I'm going to do something nice and easy, like the cosine of 15 degrees. And then you say to yourself, hey, we don't have a cosine of 15 degrees idea. We don't have some special right triangle for that. No, you don't. But you do know this. You could rewrite this as a 45-degree angle, take away a 30-degree angle. That would be the same as a cosine of a 15-degree angle. And then you say, hey, which formula am I using to get this one done? I'm using this formula right here, the difference formula. And I could rewrite this as the cosine of a 45-degree angle times the cosine of a 30-degree angle plus the sine of a 45-degree angle times the sine of a 30-degree angle. So where am I going to get this information? Don't grab your calculator and start punching the numbers in, because if you look carefully at the problems, they're going to say this. They're going to say use exact values for all of these. And that's where you got to know what you're doing. So how do I do this? Well, it's back to reference triangle town. Look, I know if I wanted to, I could draw a reference triangle that has a 45-degree angle in it, and I would do the same stuff we did right at the beginning of this. Opposite would be 1. Over here would be a 1. This would be a root 2. And I could also draw a 30-degree reference triangle. Oh, that didn't straighten out. Come on. Really? There you go. Oh, well. So here we go. That's a 30-degree angle. Opposite the 30, I put a 1. Opposite the 60, I put a rad 3. And I make my hypotenuse a 2. So how do I do this now? I go, what is the cosine of a 45-degree angle? So over here is my 45-degree reference. Over here is my 30-degree reference. So the cosine of a 45 would be adjacent over hypotenuse. I'm going to multiply that by my 30-degree reference angle. So cosine of a 30-degree would be rad 3 over 2. I'm just plugging this in. Now, I know that I have a rad in the bottom and all that good stuff, but let me just plug in what goes where, and then I'll show you how to make this easy. So I go sine of 45. Wait a minute, what's the sine of a 45? I go back to my reference triangle over here, and I say opposite, oh, I could do that. It's 1 over rad 2. And then sine of 30, I go to this reference triangle that I already drew, and I say sine of 30 would be 1/2. Now let's work some magic here. In the first fraction combination here, 1 times rad 3 in the top is rad 3. In the bottom I have 2 times rad 2, which is 2 rad 2. I am going to add that to over in the second fraction. I'm going to have 1 over 2 rad 2. Hey, they already have a common denominator. How convenient for me, because my answers are supposed to be exact values with common denominators. So I'm going to rewrite this as rad 3. Whoops, I'm running out of room. I'm going to scroll down. Rad 3 plus 1 over 2 rad 2. And you see that rad in the bottom. You're not going to find that answer in the back of the book, because they're going to take this and say, you know what, I got to get that rad 2 out of the bottom. So I'm going to take the entire top and the bottom and multiply it by rad 2. And if I do that, I'll get rad 3 times rad 2. What is that? It's rad 6. Plus rad 2 times 1. That's just rad 2. Then on the bottom, I have 2 times, well, rad 2 times rad 2 is 2, so I get a 4. So the answer I'm looking for is rad 6 plus rad 2 over 4. You cannot add the rads together and call it rad 8 or anything crazy like that. That is what your answer is going to look like. Get used to it. You see a lot of answers that are very similar in this section. That's your answer, rad 6 plus rad 2 over 4. Just on the side here, just a side note, okay? If you had something like 3 rad 5 plus 7 rad 5, you could call that 10 rads of 5. But if the rads don't match, you can't combine them. So never do that. Like in this answer, that's as good as it's going to get. You're done. Now, this is also an exact value. So that's where we're aiming. We're trying to get an exact value answer. Okay, now here's the thing with this. In the book, they will give us some problems where they say, well, let's find this. I'm going to scroll down, guys, a little bit. They say, how about we want to find the cosine of a 105-degree angle. I say, well, wait a minute, cosine of a 105-degree angle, I could think of a way to write that, like cosine of 60 degrees plus 45 degrees. Yeah, I could. And then I say, wait a minute, that looks like the sum formula. You see where I'm going with this? The sum formula. And I would say I could rewrite that using the couscous. I could say couscous, cosine of 60 times cosine of 45, couscous, minus sine of 60, sine of 45. Yeah, but how am I going to get this done? Well, I'm going to draw 2 reference triangles. I already had one of them. I can draw a reference triangle that is a 45-degree angle. You better believe I can. This is my 45-degree reference. And I'm going to go 1, 1, rad 2. And then I'm going to draw a 60-degree reference triangle. And if I drew a 60-degree angle, oops, I should have let that, there it goes. I can call this guy rad 3. This guy is 1. This guy is 2. And so I'm going to use my 45 and my 60-degree reference triangle to get all this information here. So what's the cosine of 60? Go look at your triangle. It would be 1 over 2. What's the cosine of 45? Well, it's 1 over rad 2. Don't worry about the rad in the bottom. We'll get it done later. Minus What's the sine of 60? The sine of 60 would be rad 3 over 2. What is the sine of 45? The sine of 45 would be 1 over rad 2. And just like I promised you last time, you're going to see the same type of numbers all over the place in different configurations here. That's what I got. I multiplied top times top, bottom times bottom. And then I did the same thing over in the second part. But now I have common denominators. I say 1 minus rad 3. The whole thing is over 2 rad 2. I'm going to multiply the entire top and the entire bottom by rad 2 because I don't want the rad in the bottom. My answer will not match the one in the book if I do that. So I end up with rad 2 in the top, right? I get right here rad 2 times 1 is rad 2 minus rad 3 times rad 2 is rad 6. And in the bottom, just like I had before, 2 times rad 2 is just 4. Fancy way to say 4. That is an exact value answer because it's got roots in it, no decimals. So, I hear my dog barking. Anyway, I did a couple examples here just with degree measurements. So my first one up here at the top, I did cosine of 15 degrees. How did I write it? 45 take away 30 because I know about 45s. I know about 30s. I do. And then my second example I did for you guys, I did cosine of 105, which I knew I could write as a 60 degree plus a 45. Now, I'm not going to give you guys anything that you cannot write out. I'm not. But I do want you to see something like this. I'm going to scroll down a little bit. They are going to use radians too. They're going to do this kind of thing to me, those kooks. Cosine of, and I haven't done a negative angle one yet, so let's do this one. If you haven't noticed, I'm just doing problems out of the book that are evens. There's this guy. Cosine of negative 7 pi twelfths. Holy cow. I can do this one of two ways. They're both correct. I'm going to do them both ways, and you decide which one you like the best. But I could say, off the bat, I don't like radians. I've been dealing with them for a long time, but could I take negative 7 pi twelfths and could I convert it into degrees? I could. I just realized I don't have a calculator with me, and 12 into 180 is not something I feel like doing right now in my head. But I could convert this thing into degree mode, and then I could figure out how to, do it with degrees. But since I don't have a calculator, guys, I don't feel like doing that. Here's what I'm going to do instead. I am going to use this trick that pi sixths, pi fourths, pi thirds, oh crap, I'm running out of room, and pi halves. These are my guys. Check this out, because I know a pi sixth angle is 30 degrees. I know a pi fourths angle, and you can convert these, is a 45 degree. Pi thirds is a 60 degree. Pi halves is a 90 degree. So what am I shooting at is this. All of these guys could be written with a denominator of 12. Check this out. This is 2 pi twelfths. This next guy is 3 pi twelfths. Pi over 4 is 3 pi twelfths. Pi over 3 could be 4 pi twelfths. Then pi over 2 could be 6 pi twelfths. Now, I don't know if you guys see this, but this is what I'm looking at right here. Right here. These guys. I know that if I wanted to, I could say negative 3 pi twelfths and negative 4 pi twelfths add them together, if I add them together, would I get cosine of negative 7 pi twelfths? Would I? I would. So this guy right here could be rewritten as cosine of negative 3 pi twelfths plus negative 4 pi twelfths. I could do that. I would get cosine negative 7 pi twelfths. But if I were to do that, what am I really looking at here? This is the same thing as a negative pi fourths angle, or my brain thinks in degrees more than radians. It's the same as a negative 45 degree angle. Hey, negative 4 pi twelfths, that's the same as a negative pi thirds angle, but my brain really does think in terms of degrees more so. So I could rewrite this to look like that. This cosine of negative 7 pi twelfths could be rewritten as cosine of negative 45 degrees plus negative 60 degrees. If I want to do it that way, can I? Sure. But here's what I'm getting at. Here's the thing. When they give you radian measurement, you can always think of these guys. Pi sixth, pi fourth, pi third, pi halves. We have a quick degree conversion for all of those. And every single one of them could be written with a 12 in the denominator. So you will see the number 12 in the denominator on a lot of these. What did I do? I used this trick where I could get it to here. And then I can convert it to something I know. So let's finish this one. And then you know what? We'll do some practice. So we have cosine. Let's go through it. We have cosine negative 45 degrees plus negative 60 degrees. I am going to draw two reference triangles. One of them is going to have a negative 45 degree angle in it. If I do a negative 45 degree angle, what does that mean? It means I had to go clockwise instead of counterclockwise. So when I label my sides, don't forget this guy's got to be negative because he's in quadrant 4. He's on the negative side of the y-axis. This is a negative 45 degree reference angle. I'm going to draw a negative 60 degree angle too. So what does that mean? My next angle that I draw, ooh, that's so crooked. Sorry, guys. They're not looking better. Okay, here we go. That guy's a negative 60 degreer. That means I'd have a 1, a rad 3, and a 2, but this guy's got to be a negative. Remember, the hypotenuse is never negative. So let's knock this thing out. That's my negative 60 degree reference because I'm about to do this. Let's go couscous. So I could say couscous, cosine negative 45 degrees times cosine negative 60 degrees. Plus, no, don't blow it. This is the sum formula, so we use a minus here. Minus sine of negative 45 degrees. And then sine negative 60 degrees. And we just start playing. Here we go. Let's go get it. If I wanted to do the cosine of a negative 45, I get 1 over rad 2. If I do the cosine of a negative 60, I get 1 over 2. Minus, so sine of negative 45, let's look at that. Sine of negative 45 is a negative 1 over rad 2. Times sine of negative 60 is a negative rad 3 over 2. So watch out. There's all kinds of negativity in this problem. Let's do one piece at a time. Here we go. That's 1 over 2 rad 2. Minus, I'm going to take a negative times a negative, so it's a positive rad 3 over 2 rad 2. And what I am hoping you see is that you're coming back to answers that you will, you will frequently encounter. What's the answer here? Rad 2 minus rad 6 over 4. If you clean it up, and that is an exact value answer. I'm up to 20 minutes exactly right now, but I still have one thing I got to mention to you guys, because you're going to run into this. One more thing, and then we're done. What if they gave me something that looks like this? Because they will. What if they said cosine 160 degrees, cosine 20 degrees, minus sine 160 degrees, sine 20 degrees. And they said, what is that exact value? What is the exact value of that? And I'm going to tell you the exact value of that is -1. My answer is -1. Now, it's not because I made up the question. Well, kind of it is. Because I wanted this to happen. If I have couscous and I have a minus, what I'm really looking at is cosine of an A plus B type event. That's what I'm looking at. I am doing the sum of a cosine of an A and a B. Well, what are the two angles they gave me in this? It looks like cosine of 160 plus 20. Well, that's the same thing as the cosine of 180. Now, here's where we start playing big time. Sometimes to answer a question, you need exact values. Sometimes to get those exact values, we draw reference triangles. But let's go back in time here. We don't need a reference triangle for a 180-degree angle because we couldn't draw one if we wanted to. But I do know this about my parent functions. I know that when I drew a cosine graph, check this out, when I drew a cosine graph, it started above the line, then it went back to the line, then it went below the line, back on the line, above the line. When I sketch a cosine graph, I don't know about you guys, but right here, isn't pi equal to 180 degrees? So if I want to know the cosine of 180 degrees, I want to know the cosine of pi. Well, what's the value? It equals -1, man. That's what it is. So this is what I call, when they give you this as your question, then you have to rework it. So it's like in mathematics, we go forward, sometimes we go backwards. Factoring is the reverse of foiling. Dividing is the reverse of multiplying. This way to write the problem brings us back to this. And my first 3 examples were the other way around. Well, guess what? This last example, I put it there because you're going to run into question 15 and 16. Well, what the heck? Let's just write this down. Page 212. You should be able to work through, let's do 7 through 15 odd, because I did some evens. 7 to 15 odd plus number 16. And you should be able to check your answers to every single question there, but number 16. So let me look. Oh, the answer to number 16. So answer to number 16, because you won't be able to check it, is -1. But that's as far as we're going to get on that section. It took me 24 minutes now just so you guys could do 5 questions. Welcome to